Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 9th, 2025, just yesterday. This paper introduces a new human motion dataset that is 20 times larger than any existing alternative. The paper is titled, Go to Zero, Towards Zero-Shot Motion Generation with Million-Scale Data. And as we'll see, this massive dataset allows their model to generate some incredibly complex human motions. The authors use this new resource to train a scalable model up to 7 billion parameters, pushing the boundaries of creating realistic human movement from just a text description. Also, the authors shared their implementation on GitHub, and it's pretty comprehensive. You'll find all the code for training, evaluation, and inference, along with their pre-trained 3B and 7B parameter models. They also include detailed scripts and instructions to help you get everything set up and running. Alright, so kicking things off, the first figure really sets the stage. We see two motion sequences, one for a whirlwind kick and another for a very detailed sword swing. These are generated directly from text, showing the model's ability to handle complex compositional motions, basically creating movements it hasn't explicitly been trained on. To do this, the authors use a technique called finite scalar quantization. This is a method for breaking down complex motion data into smaller, manageable pieces or tokens that the model can learn from more efficiently. Building on that, this next figure shows us exactly how they created the massive dataset that makes all this possible. It's a 6-stage pipeline for building what they call the MotionMillion dataset. It starts with raw video, first breaking it into smaller shots, then detecting the person in each frame. After filtering out bad clips, it moves to the core step, SMPL motion estimation. SMPL is a digital 3D model of the human body, and this stage extracts the precise pose and movement, turning video into structured data. Finally, more filtering cleans up any jerky motions. This table then gives us a direct comparison of how their new MotionMillion dataset stacks up against existing ones, and the difference is pretty staggering. We're talking 2 million clips, over 2,000 hours of motion. The next best, MotionX, has just over 140 hours. Beyond just size, MotionMillion also has far greater text diversity, with over 20 different descriptions for each motion. It also includes multi-person interactions in both indoor and outdoor scenes, and it's built from full-color RGB video, making it vastly richer. So with this incredible dataset, the question is, how does the model actually learn from it? This diagram lays out the architecture. It's a two-stage process. On one side, a text description is broken down into tokens. On the other, the raw motion data is first smoothed out using a wavelet transform, which is a mathematical trick to reduce jitteriness. Both the text and motion tokens are then fed into an auto-regressive transformer. This is the core of the model, which learns to predict the next step in a motion sequence based on both the text and the previous movements. Okay, so that's the architecture, but how does it actually perform? This table gives us the hard numbers, comparing their 1, 3, and 7 billion parameter models against a baseline called SCAMO. We're looking at two key metrics here. First is FID, or Fréchet Inception Distance, which measures motion realism, and for this, lower is better. The second is R precision, which checks how well the motion matches the text. And here, higher is better. The results are pretty dramatic. Their models significantly outperform SCAMO, with the FID score dropping from 89 down to about 10. But those quantitative metrics only tell part of the story. This next table gets into how humans actually perceive the results. It compares their models against others like SCAMO 3B and T2MGPT on three key aspects. First is text alignment, which is just how well the motion matches the prompt. Second is physical plausibility. Does the movement look real? And third is motion smoothness. You can see their 7 billion parameter model really excels at text alignment, scoring a 261. For the other two metrics, it's right up there with the best, showing very smooth and believable motion. So taking all these results together, what this work really shows is that scaling up, it works. By creating the massive MotionMillion dataset and a powerful 7 billion parameter model to learn from it, the authors have made a huge leap towards true zero-shot motion generation. And zero-shot generation just means the model can create motions for text prompts it has never seen before, showing real understanding. This combination of massive, high-quality data and a scalable model truly sets a new foundation for the field. Alright, that's all for today. Thanks for tuning in to the AI Research Roundup.